Overview of collaborative AI agents and critics for fault detection and cause analysis in network telemetry. Foundation models like GPT-4 and Llama can handle text, images, and video, but building multimodal models is several times more complex than unimodal ones. Multi-agent systems with specialized models deliver higher accuracy. This paper develops algorithms for AI agents and critics that collaborate through a central server to complete multimodal tasks, including fault detection in network telemetry. The problem: agents and critics must minimize overall system cost while keeping cost functions private and without inter-agent communication. The paper provides convergence guarantees for time-average active states using multi-time scale stochastic approximation, with communication overhead independent of the number of agents and critics. The method combines stochastic approximation with multi-time scale step sizes. Each agent calculates its participation probability using feedback signals from the central server, its time-average active states, and derivatives of its private cost function. The feedback signal is updated by subtracting a gain times the aggregate error between actual and desired agent counts. Agents perform Bernoulli trials to decide whether to be active. When active, they generate responses, send them to critics, and revise their responses if they agree with the critics' feedback. The central server tracks active agents and critics and broadcasts feedback signals for each modality at every time step. Time-average active states of agents and critics converge almost surely to optimal values found by the CVX solver. For fault detection on the network telemetry dataset, agents enabled with XG boosting outperform LLM-enabled agents on all metrics. The figure shows the algorithm's cost ratio evolving close to the optimal benchmark. Feedback signals converge over iterations for both modalities. For fault severity, LLM-enabled agents classify faults as critical or non-critical, and generate cause summaries using network log files stored in ChromaDB. Communication overhead remains independent of the number of agents. This work delivers stochastic control algorithms for federated AI agent-critic systems with almost sure convergence of time-average active states. Communication overhead stays independent of agent count. On network telemetry, classical machine learning outperforms LLMs for fault detection. Future directions include real-time deployment on network hardware and extension to smart energy and industrial fault analysis. Read the full paper for details.